Welcome. Welcome Web Summit. Welcome Qatar. My name is Oliver Steil. I'm the CEO of TeamViewer, and I'm delighted to talk to you today about Smart Factory and our experiences in Smart Factory and IT OT. Here we go. So before I start, just quickly as an intro, TeamViewer. You know TeamViewer, we provide remote access, remote control to equipment. We provide IT support, people helping other people. You probably got help through TeamViewer, or also you've been the helper to other people on TeamViewer. But what we've done over the last years is to move into the operational world. So we were accessing, connecting, controlling more and more machinery, equipment in an industrial environment. And I thought it might be interesting to tell you about our journey, our learnings, and also the issues and the problems in order to provide connectivity in these environments. We do believe it's very important because it's the next phase of growth for us and for many other companies. If you listen to companies here, if you are around in the world, the next big thing is to connect the real physical world. We all have a lot of IT software when we are in the office, but when we think about manufacturing, supply chain, warehousing, there's a lot to do about. And that's what we're going to talk about. First important thing is there's two different worlds, two different acronyms also. It's IT and OT. Obviously, we all know the IT environment very well. But when it comes to OT, we are less familiar. So OT, operational technology, everything that runs day to day is touching physical goods and also workers. And we need to make sure we understand both sides of the world to be able to be successful. And that's what I'm going to focus about. So what do they have in common? What is important in both? And what are we trying to achieve really? And it's both. It's all about data. And we're very well aware and used to using data in our office environment. And so are factories. They're also used to use data, but it's still a very different environment. And especially when you try to provide services coming from IT to OT, you will see what challenges you're facing. What is a smart factory about? Why are we doing this? Clearly, you have a heterogeneous set of equipment. You have machines, you have robots, you have workers. You're trying to connect the data across the whole platform, across the whole factory. You monitor production, obviously in real time. It's all happening in real time, which is a big difference to the IT environment. And then you try to do closed-loop optimization. So you get the data, you analyze the data, and you immediately feed back to machines in order to optimize the processes. And all that happens in a sometimes dusty, sometimes clean room environment, so very different from what people are used to in the IT side. Also, the factory is supplied by goods, by products. So you have a supply chain, you have a workflow and a goods flow into the factory. All of that should be digital as well and should be smart as well, because otherwise you're not realizing the benefits from these smart factories. What are the benefits? The most obvious one, and everybody's talking about, productivity and efficiency. Clearly, if you have data analytics, if you optimize processes, if you optimize the utilization of your machines, of your goods flow, you can be faster, can be more efficient, you can save costs, and you have less people in the factory. A very important point, obviously at the moment, with shortage of skilled labor, you need to optimize as much as you can. The next big piece, closely related to that, is sustainability though. If you know your machine's production, if you know the best possible way of routing goods through the factory and producing, you can save a significant amount of energy and pre-products. And that's very important, increases sustainability across the whole supply chain and production chain. And that's a big, big benefit and a big task in order to optimize that. Also, if you have more digital information, if you enable your workers in a better way in production, it's also a safer production environment. And safer in this respect means really hard safety. So less touches of harmful equipment, less accidents on the shop floor because people get their instructions, they are used to the environment, they get hints, they get warnings, they get alerts. All of that is possible if you have a smart environment, and that's a big plus. And last but not least, coming more and more, and I will show you an example later in the end, is being faster, being able to react much faster to customer desires, to specifications, to customizations. You order a product on Monday and you pick it up on Friday, a car, for example. So very, very short cycle times, only possible with digital twins and proper production planning and digitalization. So these are the benefits, very clearly, well understood, but it's not easy. And if you really look around and ask yourself how many smart factories do you really have and where can you really see them in action, it's not that easy. And the reason is the challenges between these two different environments. And it's shown here, IT, the IT stack, the server environment, and the OT stack with the robots. It's still relatively separate worlds. I show you a few examples on how IT managers work and think about the world and how OT managers work. It's actually very different. People are trying to bring these closer together. And there's many, many companies working on the IT side, many on the OT side. But if you really try to find people that try to drive conversions between the two worlds, it's not that many. Many people talk about it, but if you see what is deployed in the company, it's not that many names because it's complicated. And especially the OT people, so people on the right side, they will tell you, I haven't found it perfectly working for me, and therefore I'm skeptical. And that's what many people, many startups, and also us and other companies try to address, and I'm going to walk you through this. So why is it so difficult? It starts with the people, as always, and I give you a few very different quotes on how different people look at the world, and that is the challenges we found when we were working through the projects, and we're still finding. So if you have an IT manager, for an IT manager, it's pretty easy to collect all possible data. And they will focus on one use case, and they believe they have the data, they can analyze it, and they can create an outcome. Plant managers in the factory are starting often from a much more basic level. So they will confront you with questions like, if I would know if all my machines are running in production mode at the same time. That would already be a big finding, while the IT guys are already miles ahead in their thinking. IT people also consistently think that the shop floor is not very data-driven. And data happens in the cloud and data happens in the office, but in the production environment, it's difficult. But there, the OT managers would counter and say, that's not true. We have been running with programmable logic computers since a very long time. So we know the data, we've been using the data, just never with you on the IT side. We do it ourselves, we keep it for ourselves. And then the IT guys will say, well, that's very complicated, so we should really focus on greenfield deployments. I show you a greenfield factory later where everything is relatively easy. The OT wisdom of the side is to say, well, it doesn't take long, and your perfect greenfield factory looks like brownfield already after 6 months, because something will change, new machines will come in, and your whole nice greenfield deployment changes, and then we need to be able to adapt to it. They talk different technologies. They really have different buzzwords in the IT side and the OT side, and it's very hard to get them into one project team and work with them. And that's how to get the data. You have machines, they all produce data, how to get them. That's already a significant challenge. But then creating an outcome is the next problem. So you collect all this data, what do you do with this? And typically, on the IT side, you would very quickly look at hyperscalers. You would look at industrial cloud platforms that are available, and you would believe there's algorithms and optimization happening. Our experience, whenever we talk to OT people, is that they are inherently very skeptical, because they looked at these solutions, they looked at AWS, they looked at Microsoft, they looked at Google, and they found it not customized, not fitting well enough to their environment, and that's something you have to deal with. There is also a very different focus in what you try to do with the data and what good outcomes will look like. One thing which you all have heard about is predictive maintenance. Everybody is obsessed with predictive maintenance because you have the data, you analyze the machine runtime, you find anomalies, and you want to deal with them. That sounds interesting and sounds like a great use case, and often it is. But a plant manager would look at it differently. He has conflicting targets that he needs to work on. Sometimes it's maintenance, sometimes it's cost, sometimes it's quality, sometimes it's throughput. And that changes quite a bit on the target system. So it has to be much more dynamic in order to deal with this. And then lastly, if you deploy new software from the IT side, that's a common process. It's a well-known process. You do updates from the cloud, and you're used to certain downtimes and certain, I would say, issues when you do it every now and then. From a plant perspective, this is horrible. It's really horrible. The cost associated with a short downtime, even a short downtime, is enormous, and people will not accept that, so they have to think about it in a different way. And then lastly, securing data. Data security is a very important topic on both sides, but the paradigms, how people look at it, is very different. On the IT side, it's all about use all the data, but protect yourself in the best possible way. You have certificates, you have firewalls, you have all kinds of tools available that help you be secure. I think the OT side is much more pragmatic. So once you have your factory shielded to the outside world, then you be very pragmatic with data, and you see it here. So we share the same passwords, we only have a few computers, it all has to be pragmatic and workable, we cannot be too complicated. But the answer by them to the security problem is often, okay, make it an air-gapped solution. Make sure I'm not connected to anything in the cloud. I will not send any data outside. And that's a pretty big conflict that you need to overcome. The next piece is you also need to agree on the KPI set. If you look at typically how IT solves problem, measures productability, serviceability, mean time to resolve, and so forth, it's all well known. It's very different language when you talk to the OT side. Their key metrics, overall equipment effectiveness, that's above everything, and then setup times, cycle times, jobs per hour, defects, losses, downtime, very different measurements, and you need to bring these people together and agree on a common KPI set before you actually work and have a productive outcome. So there's a lot of POCs and proof of values that you can do, and you can put project teams together, but to make a plant manager deploy a solution in a manufacturing environment is actually a pretty hard task, and for this you need to convince them on the KPI side. So if we do a deployment, there is always a proof of value with very hard facts on the manufacturing side, and then you move from there. So once you have that, you can take steps toward this. And despite the fact it being difficult, I think there's progress being made, and I'd like to show you a few examples of companies that deal with this, ourselves, but also others, and you will see the very different ways of people approaching the very same problem. So one example is, as you can see here, is our own solution, TeamViewer, where we really take asset by asset and we connect to industrial asset and make a very first step, if you wish, try to bring all the information of the various OT equipment, OT devices into one dashboard. So you start to have an inventory like you have with your IT equipment, and at that inventory, at that dashboard, you can look at different ways. You can look from the OT side, you can look from the IT side, and you can agree on certain workflows. And that's an important step forward, which wasn't there before. So we have a use case where we connect, for example, to industrial coffee machines in the field, and it's the IT side that can manage the connectivity and the platforms, the software architecture, and can also configure the access rights, for example. And it's the operational people, the service people, the service partners that can access the machines to do the job. So it's really both sides using the same dashboard, creating an outcome on industrial equipment. Sounds easy, but you have to start somewhere, and it's not that many companies that have that combination done. That's one example. Very different example is a company called Cybers, founded in 2015 in Germany. They take a step back from what I just described, and they try to connect a complete plant, and they provide an infrastructure as a code layer that connects to all the different machines that you find in a large-scale production environment. No matter what the machines manufacture, no matter the protocols of data, it's all channeled through one gateway. That gateway still sits on-prem, so it's fully managed and owned by the plant and by the plant operator, and only after that you connect to the cloud. So that gives OT plant manager the security that they need, but it also gives the IT side the manageability and configurability to get the data flowing in the right direction for the different purposes. So very large-scale approach that can scale across multiple plants. So that's the connectivity piece. So now you have the plant connected, but what do you do next? That's a good example of a data analytics company that is specifically dealing with data in manufacturing plants. So you will say, well, there's lots of algorithms in the cloud that optimize manufacturing. So back to my example of predictive maintenance. But the reality is, if you think about all the machines that we just connected, for example, with the Cybers platform, then you have lots of different data structures, different cycle times, different data amounts, different data structures, different data items. There are also lots of changes. How do you put them all into one structure that is workable? And that's what you see here in the video. Taking the data, putting it into the right data cycle, the right update timings, and put them so in a way that you can run algorithms to create findings and then closed loops optimization. So it's a very difficult task that many companies struggle with, and that's tackled in this thing. So it's one example for one part of the chain, but you need to have the connectivity first, obviously. Then you have workers. Give another example. How do you make sure out of the smart factory that you have and all the workers that run around that you also get them into the picture? So we have a solution which is called Frontline, where you wear glasses or tablets, and this software that runs on these devices is connected to the back office system. So it's connected to the ERP system, or it's connected to the product lifecycle management system, such that the frontline worker gets data in front of their eyes and gets instructions. And thereby you involve the worker and you collect data from machines and humans and can start to optimize it in one go. And the last example is actually where you see that in action. It's Hyundai Motors, who we also work with the frontline software. They did build a greenfield manufactory a plant in Singapore to build electric vehicles. Everything is new. So cell-based production, augmented reality-based workflows, a digital twin for the whole factory, very fast cycle times. It's what I mentioned before. You order and configure a car on Monday and you pick it up on Saturday, because everything can be simulated and optimized very quickly. So that's a perfect example where things come together. Again, greenfield. 2 years later, it will be brownfield and it will run into the same complexity. So there are examples where IT, OT is converging. It's difficult, but people making steps now forward, and you see the outcomes that you want. But it's something where significant growth, because for many customers that hasn't been solved yet. So if you see, you need the convergence, you need to break down silos, you need new pieces of technology, quite honestly. You need to enable the IT side to manage the data infrastructure and the software stack on the OT side, and you need the OT to believe that this is beneficial and buy into it. It needs to be practical, it needs to be working, robust, and create the right outcomes. And if you have that, then you have productivity increases, safety, sustainability, and you get to an outcome in the physical world, which from our perspective is really the next big leap that we need to take as society to improve the economy worldwide. Thank you.